Hello guys, welcome back to my YouTube channel and my name is Dharyll from Batangas State University, and for today's video we're going to tackle about the chapter 6, which is entitled Network Layer. So without further ado, let's get started. So chapter 6, Network Layer in the Natakan is mainly focuses on the role of the network layer, and also examines it examines how divides network into groups of hosts to manage the flow of data packets within a network. It also covers on how communications between networks is facilitated. This communication in between network is called routing, and also the protocols of the OS, OSI model network layer specifies the addressing and processes that enables transport layer data to be packaged and transported. More on is the network layer also encapsulation enables data to be passed to a destination within a network or on another network within a minimum overhead. Then let's proceed to the network layer. So the network layer, or also known is the other term is the OSI layer 3, provides the service to allow end devices to exchange data across the network. So to accomplish this end-to-end transport, the network layers uses four basic processes. So these processes is first is in addressing the end devices. Second is the encapsulation. Third is the routing, and then lastly is the encapsulation. So we're going to discuss or just give some key information about those four basic processes in the network layer. So first is the addressing end devices. So in addressing end devices, must be configured with a unique IP address for identification on the network. So of course, we already know that each devices must have their own or unique IP address for the identification on the network. So next is the encapsulation. So in encapsulation, what happens here is the network layer encapsulates the protocol that the data unit or the PDU from the transport layer into a packet. Then the encapsulation process adds an IP header information. And what happened next is such as the IP addresses of the source and the destination host or the receiving. So that's how encapsulation happens. And next is the routing. So the routing, the network layer provides services to direct packets to a destination host on another network. To travel to another network, the packet must be processed by a router. So the role of the router is to select first the best spot and then direct packets toward the destination host in the process known as routing. And a packet may cross many intermediary devices before reaching the destination host. So each router, a packet crosses to reach the destination host is that is what you call the hub. Next that we are going to discuss is the decapsulation. Here in the decapsulation, for example, is when the packet arrives at the network layer of the destination host, what happened here is the host checks the IP header of the packet. After the host checks the IP header of the packet, if the destination IP address within the header matches its own IP address, the IP header is removed from the packet, and after the packet is decapsulated by the network layer, the resulting layer for PDU is passed up to the appropriate service at the transport layer. So that's what happened in decapsulation process. So I will just repeat. The network layer uses the four basic processes, which is the addressing end devices, encapsulation, routing, and then the encapsulation. Next, that we are going to discuss is the default gateway. So the default gateway is the network device that can route traffic to other networks. So it is the router that can route traffic out of the local network. Also, the default gateway is the IP address of a router interface connected to the local network. So, for example, that when a host needs a needs to forward a packet to the destination address that is not on the same network as the host, the packet is sent to the default gateway for further processing. Also, when a router such as the default gateway receives a packet, it examines first the destination IP address to determine the destination network, and the routing table of a router stores information about the directly connected routers and remote routes to IP network. So for instance, that if the router has an entry in its routing table for a destination network, the router forwards the packet, and if no routing entry exists, the router may forward the packet to its own default route if one is configured, or it will drop the packet. So that's what happened. Basically, that is all about the default gateway. So the next is the some important information here in chapter 5. So of course, a host is require a local routing table so that it ensures that packets are directed to the correct destination network. And also the local of the host typically contains the direct connection, so the local network route and the local default route, and the local default route is the route to the default gateway. And then the routing table entries can be configured manually on each router to provide a static routing, or the routers may communicate route information dynamically between each other using a router protocol. And the last thing I want to tell you is the internet is largely based on the IPv4, which is still the most widely used network layer protocol. And an IPv4 is a packet contains the IP IP header and the payload. However, the IPv4 has a limited number of unique public IP addresses available. So this led to the development of the IPv6 version of IP address. So that's it for today's video. So if you learned something and if you like this video, please leave a like and share and subscribe to my YouTube channel, and thank you for watching. Bye bye.